Let me try to get my positioning right. Hello, everyone. Happy ROSCon. My name is Steffi Pepke. I'm a co-founder at Open Source Robotics Foundation and was previously the user experience designer there, and I'm currently with Toyota Research Institute as an interaction designer.
And I'm Luis Pobel. I'm a software engineer at the Open Source Robotics Foundation.
I have a very brief disclaimer. Against our better judgment, we made our entire presentation a live demo. So we had some issues last night getting our very well-tested machine working with the AV system. So we're using a borrowed computer right now. So bear with us, cross your fingers that the live demo gods smile upon us, and we'll just hope for the best. So we're here to tell you today about Gazebo and what's new in Gazebo 7. So just to get a sense for the room, can you please raise your hand if you have heard of Gazebo? Okay, that's a good number. How many of you, that's a good start. How many of you are using Gazebo? Okay, and keep your hands up if you're using Gazebo 7. Okay, great. So it's not that many. That's not the great part, but we have a lot to share with you about what is available to you in Gazebo 7. So just at a high level, Gazebo is a dynamic simulator that lets you simulate robots in indoor and outdoor environments. And the idea is that a simulated robot is the next best thing to having a physical one. With a simulated robot, you can very quickly, easily, and cheaply make changes to your robot and your code and see what the outcome is. So if you have a robot that runs ROS, the ROS code will run the same in simulation as it will on your physical robot. The actuators and the sensors will all behave the same way. And again, the benefit there is that you can very quickly iterate through changes in your development process. So we have a very quick video to show you. It goes very quickly because we have a lot of features to get through, but just to give you a sense for the use cases and how Gazebo has been used. So we have a lot of industrial arms that have been simulated in Gazebo, mobile bases, a lot of humanoid robots. That's the Atlas. You may recognize it from the DARPA Robotics Challenge. Swarm robots, so large groups of robots, you can simulate those. Aerial vehicles. Underwater robots are also in there. Modular robots, there's support for that. We support indoor and outdoor environments, as I mentioned. We have a lot of sensors available to you, and we'll go over those in more detail. ROS integration, you may have very briefly seen ARVAs being used next to Gazebo. Number of hardware integration examples, which we'll talk more about, and Gazebo has been used a lot in competitions as well. Also education, and for prototyping. So you can simulate something in Gazebo and then build it afterwards.
So as you could see by the videos, there is a lot going on in Gazebo. It can simulate a variety of different robots in a variety of different environments. And this all starts with SD format, which is the format we use to describe everything in a simulation, from the mechanical design of the robot to all the visuals and the sensors and everything you're seeing there. I know this is a hot topic, this being ROSCon. Most of you probably use URDF. I just want to say that we come in peace. Also, we are using 4 physics engines in Gazebo right now, and you write the same SDF description of your world, and you write the same C++ plugins, and at runtime you can choose which one of these physics engines you're going to use. So this is a very good advantage of Gazebo, that you can choose the one that is most suitable for your application. The ones we support right now are the Open Dynamics Engine, ODE, Bullet, Dart, which is changing its name to Kiddo, and we're going to support that as well, and SimBody. For rendering, we're using Ogre, and rendering is not only about what we are seeing here in like the user sees, but also what the robot sees. So Gazebo is not only simulating the actuators of the robot and how the robot interacts with the environment physically, but also all the sensor data that it would get in the real world. We are also generating it inside Gazebo for your robot to be just like it would be in reality. And Ogre is being used for the camera and all the rendering of RGB data. We use Qt for the graphical interface. So all the menus that you're seeing here were done with Qt, and we're going to show some demos later that also have different menus done in Qt. We use protobuf for the messages passed between client and server. And we're using more and more of the Ignition libraries. A little bit of a big backstory here. Gazebo itself is very big and composed of many different libraries. So there is Gazebo Math, Gazebo Physics, Rendering, and each one of these is a separate library, but they are all bundled inside Gazebo right now, and we are in the process of separating them into their own packages that can be reused by other people, and in the process also making Gazebo itself smaller. We're also making sure that these libraries are cross-platform from day one, so they work equally well in Linux, Mac, and Windows. We are already deprecating all of Gazebo Math and in favor of Ignition Math, and there's Ignition messages and Ignition Transport being used in Gazebo soon as well, and we're actively working on Ignition Common and Rendering.
So before we get to the features, I want to tell you a little bit about why I'm up here. I mentioned that I'm a user experience designer, and what that means is that I advocate for the end user, and I worry about user friendliness, usability, and that the features we're building are actually useful to people. So when OSRF first started working very heavily on Gazebo a number of years ago, the primary user base was what I would consider a power user. So folks in academia, PhD students, professors, people with a lot of computer science and programming skills. And that was great, but we also wanted Gazebo to be more accessible to a wider variety of people. So these are folks with maybe no simulation experience or not a lot of programming experience to begin with. So to achieve this, we focused a lot of effort on the GUI, the graphical user interface, and making that usable. And we've gotten it to a point now where the GUI is helpful for both groups of people. So you can interact with Gazebo in a meaningful way without ever touching the command line, which was a huge accomplishment for us. I think it's a great thing. But more advanced users who may normally use Gazebo only for the back-end stuff now can use the GUI for things like debugging their model, tweaking their environment, and plotting variables that they're interested in. We've also put a lot of effort into improving the C++ API. We like to say that if you can write a plugin, you can change the world, and I'll tell you about that later. We've also added quite a bit of documentation to the website, and we'll show you those links later. So the common denominator here is usability and user-friendliness. So I'm going to talk to you briefly about sort of the workflow we have at Open Source Robotics Foundation and how a UX or user experience designer can best work with an engineering team. So the top two examples are sort of less than ideal. In the first one, you often have a UX designer designing something, and then they throw it over to the fence to engineering without really having a sense for what's hard and what's going to take a long time. And then it gets built, and then that's the end of it. There's not much usability testing. The flip side of that is the engineering team just builds something, and then maybe at the end there's some usability issues, and you try to kind of slap some user experience on at the end. And you can imagine that that doesn't necessarily have the best outcomes. So ideally, you're following the iterative design process, which is how we do it at OSRF. There's a lot of UX work up front, but the engineering team and the UX person are always talking and always working together. Those little blue spikes are usability testing and iteration on features. So that's all I will say about that. If you're interested in talking more, find me at a coffee break. So now we're going to do some demos and see how it goes. If you haven't noticed yet, this whole presentation is happening within Gazebo. We're doing it this way because it's the best way to show you what Gazebo is capable of. And some of the features we're showing you are available now in Gazebo 7, but some of them will be released with Gazebo 8. But if you're comfortable building from source, you can get everything right away. So an important part of making simulation useful is having compelling worlds. Everyone has different needs when it comes to simulation. So we've added support for scripted trajectories or actors. You may notice the drone circling the slide. This is a very simple scripted trajectory. At some point you may see a person walking around or moonwalking backwards. That is also an actor. Keep an eye out for him. We have support for height map digital elevation models, and this is really useful if you're interested in a very particular piece of terrain in the real world. So there's a tutorial online that'll show you how to cut out that terrain and import it into Gazebo to use in your simulation world. And the image you see up there is a screenshot of Mount St. Helens, and we use that in a Gazebo simulation. If you're interested in autonomous vehicles, it's also easier now to add roads to your worlds. Another important part of having a good world is having good models. We now support nested models. So if you have a model of a sensor that you want to add into another model that you're building, you can have a model within a model. We also support populations of models, so you can insert a population of models in a specified configuration. So those ROS dots up there are an example of a population. So instead of having to drag models in one by one, you can kind of do it in one fell swoop. An important part of having a good world is being able to get around in the world. And I should say on this slide, there's a little wireframe, and we put a few of these in just to give you a sense for how designs start out in an iterative design flow. So this is a very low fidelity paper prototype we did for the demo that we're about to do, the feature we're about to show you. So you can kind of see how it progresses. If you're curious to see how your model responds if you apply force or torque to it, it's easy to do that now within the GUI. And Louise will show you what happens if you shove this slide a little bit. And you might know it's gonna fall. Yay! I really appreciate your enthusiasm. This is great. So one major usability feature that we have added, which I'm very proud of, is the ability to undo. This is a new thing. So you can undo and you can redo to your heart's content, which we're very excited about. If you're interested in sort of inspecting a model from close up, we make it easy to switch between perspective and orthographic views. You can toggle back and forth. We also have these predefined view angles that you can use to zoom in around your model. And if you find that you're in a weird spot, you can hit the home button and it'll take you back to the view you were in when you first loaded the world.
One of the most difficult things in simulation is getting all your mechanical parameters right for your robot. It's very common that people have a robot that just explodes in simulation or behaves in a very weird way, and tweaking all these little parameters can be something very hard. So we're adding a lot of visualization tools to Gazebo that help you quickly look and spot what could be the problems in your model. So right here, I have a UR10 robot that I'm gonna show you some of the visualizations we have right now. So first, I'm gonna make it transparent. So I just click on it and see transparent. And then I'm gonna take a look at the joint frames, at the link frames, which are basically the origin for each one of the links. So you can see that these frames, the red, green, blue lines show the frame for each one of the links. And as you click on them, they highlight so you can quickly associate the link to the origin of that link. And you can quickly see, oh, I have the wrong axis, that's what was going on, or I have the wrong sign. Another thing you can take a look at are the joints. So you can view joints. And you can see that for each joint, you can see the joint frame, and you can see the joint axis itself is marked in yellow. In case of Revolute joints, as all the joints in this robot, you can see that they are marked with this circle here. And you can see this one is on the y-axis because it's green, this one is on the z-axis, so you can also have very quick feedback on where the joints are placed. Another important thing to look at are collisions, and all the robots basically have collisions and visuals. Collisions are basically what the physics engine can see, and visuals are what the rendering can see. And in general, you want to have collisions that are formed of simple shapes. By simple shapes, I mean boxes, spheres, and cylinders. You want to approximate the shape of your robot as good as possible with these simple shapes. Here we can see that you have all these cylinders approximating the visual shape of the robot there. And these are the shapes that actually are going to collide with each other and so on. So let's turn off collisions and let's take a look at the center of mass. So for each link, we can see the center of mass of that link represented by a sphere that has this, that is a sphere of lead, the very heavy metal, that has the same mass as your link. So if the sphere is as big as your link, it means that your link is as dense as lead. And maybe there's something wrong there, maybe your robot's just heavy, but it gives you this notion of if something is wrong, or maybe the center of mass is completely away from your robot, which happens more often than you would think, and you can quickly see that. It's also good for you to have a notion of how the mass is distributed in your model. So sometimes you can see, oh, there's more mass on this side, that's why the robot is behaving kind of weirdly. So I hide that for a bit. And this one is really cool. It's the inertia visualizations. And inertia is something that is really hard to get a real intuitive idea about. It's a matrix. It has a lot of values. Nobody says, like, my robot has inertia of 1 point something and X. And nobody has an intuitive idea of this. So when you're just tweaking the numbers, it's kind of hard to see what's wrong. But when you visualize it, you can quickly spot the mistakes. So here, for each link, we show a box that has the same inertia as your link, as if it was a box of uniform density. And in general, you want this box to kind of match the shape of your link and the size of it. Of course, it's just an approximation. Your real robot's probably not going to have uniform density, and this might be dislocated a little bit, but it already gives you a good idea of where the problems could be coming from. Finally, we're going to make a wireframe view, and I'm going to turn on contacts. So contacts is not as much for you to debug one model, but more for you to debug how models are interacting with each other. You can see that when the robot hits the slide, we can see these points here. And this is where the physics engine is actually calculating the collisions. So you can quickly take, if you have your robot interacting with the objects, you can quickly see where they're touching or not.
Great. Louise is going to show you the building editor. So this is a tool that lets you create very simple models of a building just using the GUI. And again, there's an example of a low-fidelity prototype, and you'll see the current state of the building editor.
So let's open the building editor. I'm going to place the view here. So we have here on the top, it's the 2D view of our building, and on the left here we have a palette with a lot of options for our building. So the first thing that you can do in the building editor, which is really cool, is import a floor plan of an area that you already know and you just want to draw that. So we have a floor plan here of a little place. So we import it. If you know the resolution, you can just type it here. If you don't, you can kind of click on 2 points in the image and have a rough estimate. Oh, this is about 5 meters, and we scale the image for you. And now it's just about starting to draw walls on it. So you can just, here with the wall tool, draw. You can see that they are showing up in the 3D view as I'm drawing on the... Oh, this mouse is really fast. So I'm drawing here. Let's put another wall here. You can also add stairs. And everything that you're adding in your building, you can just double-click it. You can double-click it and see and tweak all the numbers if you want them one by one. We can add doors and windows. So the doors and windows right now are basically just holes in the walls. So this is going to be cut out of the wall once the building is saved. Let's place a window here, and you kind of can see because what you're drawing is on top of your floor plan. So you can quickly, with hotkeys, visualize and hide one and the other to see the other one and have a notion of what's going on. So let's make it a little bit bigger. You can also add colors. So you just click here. There are some preset colors. You can also click on more to add your custom colors. You can add textures here. Just click on things around and make your building very ugly. Then you can also add another level to your building, and it just copies all the walls from the previous one. You can always just click on them and delete them and do what you want. So let's close this, save it, and then we're going to be back in simulation with our building ready to be used. You saw that a hole was cut out from the floor to give way for the stairs, and here inside the building we can see the windows and things like that. Oh wow, well, what happened here? Oh, I was totally playing with this earlier. Okay, this looks good. So this is the building the model editor, and the model editor is more general than the building editor. That you can edit any robot and any object in your scene right there on the spot. So to edit an object that is already in simulation, you can just right-click it and say Edit Model, and you're going to be inside the model editor. I'm going to delete this because I was playing with this earlier. So the first cool thing that you have in the model editor is the schematic view up here, and it shows you all the links and nested models that you have in your model and how they are connected by joints. The first thing we're going to do here is insert some simple shapes. So if I insert a cylinder here, it's going to insert a link that has a visual and a collision that are both cylinders. You can just use the scaling tool to scale it, and rotation tool and so on to make it the shape that you want. You can also import Collada meshes and STL meshes, and you can extrude SVG files, which are 2D files, into 3D shapes. You can also right-click any link in your model, and here you have all the options that you would have in SDF, and you can just come here and tweak the values and see the changes in real time. So like if I make it blue, you can see that it turned blue immediately. We can use the alignment tools, so I'm gonna select these two and align them on the top here, and just place it there. Let's try to move this one to kind of match that target that we have on the, right here. And you can use copy-paste, so if you select it and you do Ctrl-C, Ctrl-V, you have another one of the same link. So let's also align this one here. Again, just using the alignment tools. Okay, and let's move it a little bit here. Let's see what I'm making. We can also insert nested models, so you can get any model that is in the Gazebo Online database right here, or any models that you have locally installed. So I'm gonna get a. Where did the Hokuyo go? Did I close it? This is Dirk's computer. I can try to insert it. Where you found it? Hokuyo. Okay. Oh, that downloaded fast. Thank you, Bosch, for the internet. So I'm gonna rotate it here, and let's align that too. So we click here, and then let's align it. And there you go. So now we have 3 links and a nested model in our model, but they are not connected to each other. Let's make some joints. So there's the joint creation tool here. You can click on the parent link and in the child link, and we create a joint. Then we can see the axis is not where we want. We want it to be green, which is Y. So we just choose it here, and we can quickly move it here on the Z up, which is the blue one. And let's move it a little bit more up. Yeah, that's good enough for now. So we create it, and then let's create another joint between this one and this one. So we also want this one. This one, let's make it in -Y, so it matches the other one. And let's move it in -Z, which is the opposite there. I'll just move it a little bit more. Let's go. Okay, great. Now, let's connect the Hokuyo, otherwise it's going to fall off. Let's just make a fixed joint here. So I click Fixed, Create. That's it. Another thing we want to do is make our model heavier, because now that I attach a bunch of stuff to it, I don't want it to fall off. Let's just make it tungsten. And it's very cool because once I select the density, it's going to calculate the mass and also the inertia matrix for me based on the shape automatically. Okay, so I think our model is good. Let's save and exit. Okay. And we're back in simulation, we're paused. So let's just hide this and press play, and that's it. So we have a very ugly double pendulum there.
So now that we have this double pendulum, we can show you the plotting tool. And the plotting tool is really neat if you're interested in plotting a variable. And it can be a Gazebo topic or pretty much any piece of physics data. So you can see Louise is using the search feature to look for the link she's interested in. And then you can drag the variable onto a plot, and it just pops up immediately. If you can have 1 or more variables per plot, or you can have a whole bunch of plots, kind of whatever you're interested in. And just add one more. And there's an export tool down at the bottom if you want to come back and check out the plot at a later date. Yep. So now we're going to talk a little bit about sensors. These are the ones that have been added recently. It's not a complete list. And I should say that a lot of these came from outside contributors. It's not just OSRF working on this. The altimeter and, I wanted to say the beauty of simulated sensors is that they're free and you can very easily swap them in and out. So if Louise changed her mind and didn't want the Hakuyo, she could have easily swapped it out for something else very quickly. So the altimeter and the magnetometer were added recently in response to the UAV craze that's sweeping the world. The wide-angle and depth cameras were added recently. You can use the sensors on a robot, or if you just want to do computer vision, you can use them as standalone sensors as well. There's an example of a little camera there, just checking out the house. And we've had a request for radar for autonomous vehicles. That's not done yet, but is in the works. Great, so now we have the logging and playback tool. So this is great if you want to go back and relive a simulation after you have run it. This is one that we recorded earlier. It's Turtlebot bowling with beer cans. And you can scrub back and forth in simulation, change the view angle, and you can use all of the same introspection tools that Louise showed you a little while ago. So this is a great tool if you want to come back to what you did before. We also now have a screen capture feature, so up in the top right, if you want to create just a regular video, you won't be able to change the view angle at a later date, but this is if you want to send a quick video to someone, tweet it, whatever it is you do with videos, that's available to you now. New plugins. So as I mentioned, if you can write a plugin, you can change anything in the world within Gazebo. These are really powerful tools to help you control either the back end or even the front end. The example, there's a little plugin on the top of the slide, the blinking Halloween plugin. There's a buoyancy plugin if you're working with underwater devices, an elevator plugin. This whole presentation was made using a GUI overlay plugin. So you can see that it's a really powerful tool to help you control Gazebo and get it to really fit your particular use case. We've also spent a lot of effort on hardware integration. So if you have an Oculus or a Polhemus 3D classes, you can use those, and it's a great way to kind of bridge the gap between simulation and the real world. You can use these gadgets and control what's happening in the simulated world with your physical body, which is pretty neat. The top photo is an example of a demo we did for the DARPA Robotics Challenge that's using an Oculus and a Razer Hydra. And the bottom is a Polhemus with 3D glasses. And you can see on the screen in that image, we're using a GUI overlay plugin for that project. There's a custom GUI on the left side. And the arm that's being simulated is a prosthetic that was being tested for use on folks with transradial amputations. So it's a great example of how plugins and hardware integration can work together. We're doing great on time. So what's next? Those are some of the new features. We weren't able to go over everything, but we have, that was kind of a grapevine. So we have some GUI-specific features that we're working on. One is a terrain editor, so you'll be able to, within the GUI, create a customized terrain. We're working on a visual redesign slowly. If you notice, the plotting utility had a much different look and feel that was based on Google's material design. So we're slowly moving in that direction. That was kind of a prototype, just to get a more cohesive look across the whole system. We're working on a GUI console as well that'll help you with debugging within the GUI, and graphical inertia resizing. So if you remember the pink boxes Louise showed you that represent the inertia on the introspection tools, you'll be able to, if it's too big or too small, you'll be able to drag it to get it to be more what you want it to be. So you can quickly tweak your robot that way, or your models that way. We'll also be adding graphical tools for physics validation, and a bunch of other stuff. On the non-GUI side, we're working on prop shop integration. And PropShop is an online database of models, so you can share your models and download other people's models that they've contributed. So it'll let you have a wider variety of models to use within simulation. It's going to be a really cool thing. Woo! There's CloudSim and GZWeb. You'll hear more about those later. Ian is giving a talk on that. But at a high level, if you couldn't guess it from the name, CloudSim lets you run simulations in the cloud. We'll be working on improving SDF and URDF support, and working on adding deformable shapes. There's a complete list of the roadmap at, I think it's gazebosim.org/roadmap, something like that. Status. If you're interested, you can look there. So you may be thinking at this point, how do I get me some Gazebo? And the answer is on this slide. I'm sure you all know that each ROS version ships with a particular version of Gazebo, but it's possible if you follow that link to make your own combination. So if you don't want to switch to a different ROS distribution, you can customize it and get a newer version of Gazebo working. And it's also important to note that starting with Gazebo 7, the current release, we're now synced with the ROS releases, so it'll be easier for you to stay up to date. So here we have some resources if you want to learn more. Those folks down there are the Gazebo team at Open Source Robotics Foundation. But again, they're contributors from all over the world. And if you check out that QR code, if you're into that, you can get our links to the slides. And with that, we have more time than expected for questions. Thank you for your attention.
So we've got a few minutes for questions. There are 3 mics in the room, left, center, and right. Please go to a mic because we're going to record and broadcast the questions for the audience.
In your last slide, you showed that there's a Gazebo wrapper. So for example, if I'm using Indigo and currently Gazebo 2, can I jump to Gazebo 7 and integrate it there?
Yes, if you check this link, there is a tutorial on how to make your combination of versions.
Okay.
All right. Will all plugins be focused on C++, or will there be options for other languages?
Yeah, right now, we only support C++ plugins. Maybe in the future, there will be wrappers for other languages.
The model editor is pretty fantastic. Will you support importing from CAD at all?
Yeah, we support, you can bring your Collada files or STL files. We're also starting to work on OBJ files as well, but not the whole setup, like a SolidWorks model with all the links and joints. You can't import the whole thing at once yet, but just the meshes to use in your model, yes, it's there already.
On the subject of the model editor, if I were to want to bring in a model and tune it and then run it again for repeatability, can I save to an SDF file or export to that, or is that something you have roadmapped?
Currently, it saves in SDF. Currently, it doesn't save into URDF yet, but SDF, that's the format we're exporting in.
Cool, thank you.
I have to say that was a super cool presentation and totally awesome to run the whole thing in Gazebo. Amazing. The question I have is we do a lot of multi-robot systems and we record a ton of bags, and typically if we have a problem we're visualizing it after the fact by playing the bag into RViz. And I'm wondering if there was some kind of way that we could synchronize multiple bags and then reconstruct and use Gazebo as an after-the-fact visualizer for something that took place in the real world. And so I'm wondering how kind of accessible the data format is that you're using for that playback scheme.
So the format that we record the log files right now, it's in SDF. It's state It's a state tag that we record periodically. I have never seen anyone converting from ROSbags to Gazebo log files, but maybe there's some people doing it already. You can't play ROSbag directly into Gazebo, unfortunately, but yeah, just the Gazebo log files themselves.
Well, definitely the killer app is the scrubber. I mean, that's a total win, right?
Yeah.
Are there any plans to allow for import from common SLAM packages, so basically ROS maps?
Importing from ROS maps?
Yeah, any of the various ROS map formats. More simply than a building editor, I would say.
Yeah, I don't know if we have any plans for this. I don't think we do.
Thank you.
Hello. I have more of like two half requests, half questions. One of them regards the API of the code. I know that there's been a lot of changes and that it wraps around different physics engines, but I see some inconsistency in things. Like you can do supposedly different functions do the same thing, but actually documentation kind of lacks and you need to trial and error all of them until you actually realize which one works in this version and not yesterday. Is that planned to kind of get finally cleaned up?
Yes, the question was about the API and some inconsistencies in documentation with the API, and inconsistencies on what the documentation say and what the calls actually do, or something like this. Yeah, that's unfortunately something we are aware of and that we are actively trying to work. And most of the features that are there, they are not documented well. It's because also they are not very tested very well. So we would recommend you use the calls that are better documented, because those are also better tested.
Okay, and the second one, I think people that use Gazebo experience this.
Can you talk a little bit closer to the mic?
Yeah, sorry. When you just kill Gazebo with Control-C, just make it close fast, please. Like, it takes forever.
Okay. It doesn't want to go.
Yeah. Okay.
Noted.
Noted.
Hi. Might I say that I speak for everyone in the audience when I say, wow, wonderful presentation you got going there, and I can't wait to get myself some Gazebo. So what I was wondering was, what kind of a bug reporting and patching up system have you got in case the users experience some kind of bugs or errors with Gazebo?
Bug reporting. So currently we have Gazebo is hosted on Bitbucket, and we have our the issue tracker there, so you can report bugs there. There's also Gazebo Answers, which the link is here, which is more for questions and answers, kind of like ROS Answers as well. But yeah, most of the bug reporting happens through.
All right. Thank you. Good to know. And once again, awesome presentation.
Thank you.
Hi, Dan LaFar from George Mason University. Question about your simulation time. Sometimes my calculations require longer than your time step. Is there a way to trigger your next sim time update?
Yes, from a world plugin, you can basically kind of run the world in paused mode and call the update yourself at every iteration as fast as you want.
What distro was that released with?
I believe this works with most Gazebo versions. Don't quote me on that.
Thank you.
Hi, great presentation. I think you're giving Prezi a run for their money. I was just curious, has anyone tried to run like a simulated production line, like for example, like manufacturing a car or something? Or is it possible?
I don't think I've seen a full one.
Well, personally, we haven't seen a full production line being simulated. We've seen individual industrial arms with conveyor belts. There's even a couple of them in the video that we showed, but I've never seen the whole production line. That would be really cool.